Hey everyone, and welcome. So today we're going to tackle a topic that sounds really complicated, differential equations. But trust me on this one, by the end of our session, you'll realize it's actually much easier than its name makes it sound. So, are you ready? Let's dive right in.
First things first, let me ask you something. You're scrolling through YouTube or Insta Reels, right? And you see these videos that just blow up, millions and millions of views. Have you ever stopped to think, how does that even happen? What's the secret sauce behind a video going viral? Well, in the world of math, that secret is all about the rate of change. It's just a fancy way of asking, how fast is something growing? Imagine you're a content creator. Your follower count is Y. The speed, or the rate, at which you're gaining new followers, well, that's what we call the derivative, dy by dx. It's literally just a measure of how quickly your follower count is changing. Okay, now let's flip that idea on its head. What if you knew exactly how fast your followers were growing every single hour? You know the exact value of your dy by dx. So, the big question is, can you use that information, that rate, to work backwards and figure out your total number of followers at any given time? And the answer is absolutely yes. You actually already have the perfect tool to do this. Remember integration from calculus? You know how it's the exact opposite of differentiation? So, if taking the derivative gives you the rate of change, then doing an integration on that rate, well, it takes you right back to the original total amount. And here's the kicker, the big reveal. This whole process that we just talked about, starting with the rate of change and using integration to find the original function, that is exactly what solving a differential equation is. See? You've already done it, and you didn't even know it had this fancy name. All right, so now that you've got the basic feel for it, let's get a little more formal and look at the actual textbook definition. So what exactly is a differential equation? So here's the official definition. A differential equation is simply any equation that has a derivative in it. That's it. If you see a dy by dx, or maybe a second derivative, d squared y by dx squared, yep, you're looking at a differential equation. It's just an equation that shows a relationship between some function and its rate of change. Now, this is probably the most important difference you need to get. With a regular algebraic equation, right, like the one you see on the left, what's our goal? We're just trying to find a number, a value for x that makes the equation true. But with differential equations, the game completely changes. We're not looking for a number anymore. Our goal is to find an entire function, a formula for y in terms of x. So the solution isn't just one point, it's the whole graph, the entire curve. Okay, just like how you might sort your music into different playlists based on genre or mood, we also need a way to classify these equations. It helps us figure out the best way to solve them. And the two main ways we do this are by using something called order and degree. Let's break them down. First up is order. And honestly, this one is super easy. The order is just the highest derivative you can find in the entire equation. Think of it like ranks in a video game. If you have a first derivative, which is like a level 1 player, and a second derivative, a level 2 player, the highest rank is level 2. So the order of the equation is 2. That's all there is to it. And next, we have the degree. Let's stick with our gaming analogy. Once you've found your highest ranked player, that highest order derivative, the degree is simply its power up, or just its power. But, and this is a really important but, there's a special condition. This only works if the equation is a polynomial in its derivatives. Now don't worry about that fancy term. We're going to see exactly what it means right now. Okay, let's put this into practice with an example. Now, this is a classic question designed to trick you, but once you know the rule, you'll never get it wrong. Take a look at this equation. Pause for a second and think, what's its order and what's its degree? All right, let's walk through it. First step, find the highest ranked derivative. In this equation, we have a third derivative and a first derivative. The highest is clearly the third one, so that's our order, it's 3. Easy. Now for the degree. Remember the rule, you have to look only at the power of the highest order term. What's the power of our third derivative term? Well, it's just 1. So the degree is 1. That power of 5 on the other term, it's just there to distract you. You have to completely ignore it. The degree is only the power of the highest ranked derivative. Okay, so let's get back to that special condition I mentioned earlier. Remember how I said the degree is only defined if the equation is a polynomial in its derivatives? Well, this is the part that can be a little tricky, and it's the reason why sometimes the degree is not defined. So have a look at this example here. We've got sine of d squared y by dx squared plus dy by dx equals 0. Finding the order is still simple. The highest derivative is the second derivative, so the order is 2. No problem. But what about the degree? So here's the problem. Our highest derivative, the second derivative, isn't free. It's kind of trapped inside that sine function, almost like it's locked in a box. For an equation to be a polynomial in its derivatives, all the derivative terms have to be out in the open. But here, our highest derivative is the input to the sine function. Because it's stuck inside, we can't really talk about its power in the normal way. And that brings us to our final rule for today. If the equation is not a polynomial in its derivatives, which basically means a derivative is stuck inside another function like sine or log, or even e to the power of something, then the degree is simply not defined. So for that example we just saw, the order is 2, but the degree is not defined.
And that's pretty much it. Awesome job! We've covered all of the basics of what these equations are. So before we wrap up, let's do a super quick recap of the main points. So here's what you need to remember. 1. A differential equation is just an equation with derivatives. 2. Its solution is a whole function, not just a number. 3. The order is just the rank of the highest derivative you see. 4. The degree is the power of that highest derivative. And finally, if a derivative is trapped inside another function, the degree is not defined. Got it?
And there you have it. That's your introduction to the world of differential equations. You now know what they are, and you know how to classify them using order and degree, which is a fantastic first step. So now that you can spot them and sort them, are you ready for the next adventure, learning how to actually solve them? We'll get into that next time. Thanks for joining me today.